Today we're going to learn how to factor binomials using a perfect square root method. The word factor means we're going to break things down into its smaller parts. A binomial, the prefix bi, means the number 2. So everything that we work with will have 2 parts to it. Let's notice the 4 examples at the bottom. 1, 2 parts. 1, 2 parts. 1, 2 parts. 1 and 2 parts. This technique only works when it is a binomial with 2 parts. A few other things that must happen. Perfect square root. It has to be very special numbers that have perfect square roots. So number 1, the numbers must have perfect square root. We're going to test for that using the calculator in a moment. Number 2, must be even exponents. So let's notice the 4 examples. The exponent 2 is an even number. The exponent 4 and 14 are even numbers. The exponent 8 and 12 are even numbers. The exponent 8 and 12, again, even numbers. Lastly, it must be subtraction in the middle. So let's notice the 4 examples. Subtraction in the middle. Subtraction in the middle. Subtraction in the middle. And subtraction in the middle. When we break these problems down, we will create 2 sets of parentheses. One parentheses will always have a plus in the middle. One parentheses will always have a minus in the middle. Every time. So let's go back and look at that first step. Numbers must have a perfect square root. How do we test for square root on the calculator? Well, here's the keystrokes that we'll use on our calculator. On the left side of the keypad, we'll find the second button that we've used before, and we'll find the X squared button. Okay. Let's take a look at the calculator for those right now. So on the left side of the keypad, we have our second button, and we have the X squared button. And if you'll notice, right above the X squared button is our square root symbol. So to access the square root symbol, we press second, and we press the X squared button. And that brings us to our square root symbol on our calculator. So we'll go through that again here in just a moment. In the EX example, the square root of 4. So the keystrokes that we'll use to test for that and what it looks like on the calculator. So second X squared 4. Second, the X squared button and the number 4. Enter. And it gives us the square root of 4 equals 2. So for each of these examples, we're going to test the numbers to see if they have a perfect square root. Now, let's follow through the rest of this EX example. The X squared, there's 2 of them. X squared, X to the 2, means there's 2 of them. So we split those 2 up. X in the first parentheses, and an X goes in the second parentheses. It's always 1 plus and 1 minus. The square root of 4, a 2 goes in one parentheses, a 2 goes in the other parentheses, and we're finished. Now let's practice the 4 examples together at the bottom of your notes. Example number 1. Again, let's check our 4 items, our 3 items. Even exponent, We do have subtraction in the middle. Now let's test if 16 has a perfect square root. So let's go to our calculator. Second square root 16, enter. And 16 does have a perfect square root of 4. That tells us this problem will work. I'm going to set up my two parentheses. The x squared, or x to the 2, since there's two of them, we split those up. One x goes in the first parentheses, one x goes in the second parentheses. 1 plus, 1 minus. The square root of 16, the number on the calculator was 4. 4 and 4. And there's our final answer. Let's take a look at example number 2. Immediately on example number 2, I noticed two major differences. We have two numbers to test, and we have x and a y. So let's go through our 3 items to check for. 4 is an even exponent, and 14 is an even exponent. We do have subtraction in the middle. Let's test the square root of 9 and the square root of 25. Square root second, let me do that again. Second x squared for square root 9, and that's a perfect 3, so it works. Second x squared 25, and it's a perfect 5, so it works. So yes, this problem will work. Let's set up our parentheses. The square root of 9, 3, 3. X to the 4. We want to split that up so there's the same number of x's in both parentheses. That's why it has to be an even number. X to the 4, when we split that up, we want 2 of them in the first parentheses and 2 of them in the second parentheses. 1 plus, 1 minus. The square root of 25. Again, still on the calculator, square root of 25 was perfectly 5. So 1 5 in the first parentheses and 1 5 in the second parentheses. Y to the 14. We want to split 14 up so there's the same number of y's in each parentheses. So to split 14 up in half, it's y to the 7 and y to the 7. And there's our final answer for number 2. Let's now try number 3. Same 3 things to always test for. 8 is an even exponent and 12 is an even exponent. We do have subtraction in the middle. So now let's test, does 4 have a perfect square root and does 81 have a perfect square root? Second, x squared, 4, enter. Perfectly for a 2. Second, x squared, 81, enter. It works out perfectly with a 9. So yes, it does work. Set up our parentheses. The square root of 4, 2, and 2. X to the 8th. Split those up so there's the same number of x's in each parentheses. That's going to give us x to the 4 and x to the 4. It's always 1 plus, 1 minus. Again, going back to the calculator, the square root of 81 was 9 and 9. Y to the 12. How can we split up 12 so it's the same number of y's in each parentheses? Y to the 6, y to the 6. And that gives us our final answer for number 3. Our last example with this handout of notes, problem number 4. I think some of you are able to go ahead and work ahead on number 4. But let's see what it looks like together. 8 is an even exponent. 12 is an even exponent. Subtraction in the middle. The biggest thing for us to really test, do those numbers have perfect square roots? Second, x squared, 25. Enter. And it works out perfectly to be a 5. Second, x squared, 196. Enter. And it works out perfectly to be a 14. So yes, this one will work. Setting up our parentheses. Square root of 25, 5 and 5. X to the 8th, we split that up evenly. X to the 4th, x to the 4th. 1 plus, 1 minus, 196. Again, that square root number was 14. So 14 and 14. And y to the 12th, split that up evenly. Y to the 6, y to the 6. And there's our final answer for number 4.